So welcome back to the course on how to design a carbon footprint calculator, or the course on how a carbon footprint calculator actually calculates the carbon footprint of an individual or for a family. We had seen that a carbon footprint calculator uh, actually asks for the data on electricity consumed by the family, and we said that we should ask for the monthly data on the electricity consumed. Now the unit of electricity is kilowatt hour, kWh. Okay, so if you look at the bill, you will find that so many units, so many kWh is consumed by the user. Let us say that that is a monthly bill. Multiplied by 12 would give us the annual electricity consumed. And we said that uh, for different locations, or for the different sources of electricity, the emission factor will be different. We also said that for India, for example, we take the emission factor as about 1.07 kgs of carbon dioxide equivalent per kilowatt hour of electricity. Now, how is this obtained, and why is it important for us to get the correct emission factor? It is because the emission factor is function of how the electricity is generated. So if it is generated from coal, the emission factor will be different. If it is generated from natural gas, the emission factor would be different. If it is the nuclear electricity, the emission factor would be different. If the electricity comes from solar or wind, the emission factor would be different, right? If the electricity comes from large hydroelectric power plant, the emission factor would be different. Now, how do we know? We have any state, if it is America, we know how much of that electricity comes from renewables, how much of it comes from fossil fuels. If it is India, we must know how much of the electricity comes from renewables, how much of it comes from coal, right? So using that mix, that is how much comes from coal, how much comes from renewables, we can calculate the emission factor, right? And once you know the emission factor, it's straight calculation. That will be multiplied with annual electricity consumption, that would give you the annual carbon footprint per family, and divided by number of family members, that gives us the carbon footprint generated by an individual because of his or her electricity consumption. Okay, so how does a carbon footprint calculator arrive at the carbon footprint? By using the data of the electricity bill and by knowing the emission factor for that electricity. Okay, how is this emission factor calculated, uh, and how do you get it from the basic thing? So you can skip this if you find it difficult, but try to just concentrate and see whether you understand how the emission factor is calculated. For example, I had shown in this slide how the emission factor of 1.07 kgs of CO2 has come for Indian case. In India, the power plant efficiency I had taken as 30%. I had taken the calorific value of the coal which is used in India as 16,000 kilojoules per kg, and I had taken the coal consumption to be 0.7 kgs per hour. Okay, so by knowing the plant efficiency as 30%, by knowing the CV as 16,000 kilojoules per kg, and for every kilowatt output, by knowing the what is efficiency, I can calculate the consumption to be 0.75 kgs per hour. Okay, so in the Indian case, on the average basis, you can say that every hour the coal consumption would be 0.75 kgs for every 1 kilowatt output. Okay, this gives us the emission factor as 1.43 kgs of carbon dioxide footprint. Okay, so 1 kg of coal, when it is burned in the Indian power plants whose efficiency is 30%, that gives us the carbon dioxide footprint as 1.43. Right? Now, how this 1 kg is 1.43, then how come this 1.07 arrived? So, we say that 1 kilowatt hour, right, the emission factor is 0.75 kgs, right? in the Indian case. So if the Indian case, if the emission factor is 0.75, that gives us the carbon footprint as about 1 kg for every unit of electricity generated. Okay. So this is how the emission factors are calculated.